Hello, and thanks for joining me again for my new project. This is another project that I have to say is going to test me quite seriously. I've finally decided to get down and make myself something I've wanted for a very long time, which is an electric heat treating oven. Why? Because I've been getting more and more into blade making and knife making, and I need to be able to heat treat without every time lighting the forge, getting it to heat, trying to guess the right temperature. With a heat treating oven, I can set the temperature literally to the degree. It will hold that temperature, so I can do some very accurate heat treatment, annealing, normalizing, tempering, etc. It's a tough one. I've done a lot of research. I've watched a lot of different videos, and I've come up with something that I hope will be very effective, and also something that I think most people who can do a bit of welding, who have some basic skills, can do, because that's what I've got, is basic skills. So please, if you enjoy it, remember to push that like button. It means a lot to me. Please leave comments, tell me what you think, and of course, ultimately, if you enjoy it, please subscribe. Thank you so much. So I took it upon myself to watch every video I could in terms of making these things, and I've done some reading on some websites, on some forums, etc. And I decided to make the one that was right for me, and I'm not saying that this one is the right one for you, but what were my criteria? Well, the main criteria was that I didn't need it to be very big. I needed something that was going to satisfy my needs in terms of making blades, and also I'm very interested in doing some other stuff like makumigane and various other processes that will need a degree of forge welding, but also at very specific temperatures. So I don't need a huge amount of space in here, but having said that, this is giving me some pretty decent dimensions. I've got it 10.5, well, just over 10 centimeters in width. I've got, what is it, probably nearly 40 centimeters in depth, and in height 11 centimeters. So that's a pretty decent size. A lot of the ovens I've seen out there, my biggest problem with them is that they're incredibly over-engineered, and that's probably because they're being made by people who are far more intelligent than me, far better at this sort of stuff, but I just can't face having to go through all that for making what is basically a box with heating elements and some electronics. I wanted something simple that's not going to take me years to build, and obviously one thing that they all have in common is the use of these insulating bricks. One, because they're incredibly efficient, but secondly, because they are incredibly easy to work. You can cut into them with practically anything. I mean, for any of you who haven't used these before, really, in terms of sawing and gouging a shape, they're a doddle. A lot of the designs I've seen are going into all kinds of strange cutting of tenons and mortises and all sorts of things to join these. One in particular which I liked was Blackbeard Project's version, which was literally 4 bricks that way, 4 bricks for the lid, 2 bricks down the side and 1 at the back. For me, I think that works really well without any excess sawing. As it happens, I did have to do some extra sawing because in order to get this size reasonable, I had to saw these down widthwise, because the bricks that he was using to get similar proportions were 2.5 inches wide, whereas the ones you get here in the UK all seem to be 3 inches wide. That may affect the amount of temperature it can withstand, although his oven withstands very high temperatures, so I'm not worried about that. So all I really did was I cut these down to 2.5 inches. So I cut 1/2 inch, and it literally was that easy. You'll see me doing it in a minute. And this back piece, to get the run for the coil, again, I cut out a little inset here, but again, absolute doddle to do. The other thing that a lot of the other ones use instead, which I think makes life more complicated, is they use high oven sealant. It comes in a sort of tube like silicone. I'm sure incredibly efficient, but the problem with things like that is you need to have extremely flush surfaces. So I've seen a lot of people going through an enormous amount of work, and more importantly dust, trying to get everything absolutely level so that that high temperature adhesive will work. Again, I'm very impressed by this very easy to use pre-mixed refractory mortar. It's worked incredibly well. It's really easy to apply. I've made a bit of a mess of it because I've now realized that I had to be a bit more careful than I was, and nobody's ever going to hire me as a bricklayer, that's for absolutely sure. And you can see actually, particularly on the roof of the kiln, I made a bit of a mess. But you know what? I'm going to sand some of this down. It's not critical because, again, the mortar that I'm going to fix this on with is going to give me some leeway in terms of squareness. The only thing I have to worry about really is fitting the angle irons along the edges, etc. But I think it's square enough for that anyway. And again, I've got a bit of latitude, and as you will see in a second, I might have to file some bits down to make them fit. The coil itself is made out of this stuff, which again I think most people have been using, which is Canthal wire, which is used in vapes and electronic cigarettes. I went for a 20 gauge one. I couldn't quite get the one I wanted, which is 0.81 mil in thickness, and it's made a coil that looks like this. There are various methods on how to make this coil. I'll show you the one I use, which again was hugely simple. You don't have to build a whole lot of stuff. But having said that, my version does need somebody's help. So if you don't have anybody to help you, my method won't work. I've made a much bigger coil than I'm going to need, but that's only because I'd never done it before and I wanted to have some spare. But that's going to fit in very nicely into these grooves, which I made with a rasp and a file. Well, I had a bit of a disaster, and the fence on my multi-material table saw or chop saw has broken. So that's the end of that for this project at the moment. I have ordered a spare part, but that'll take a while. So I'm going to have to finish everything on the metal bandsaw, which is much slower, but we'll still do the job. So the next bit of fabrication I wanted to get into was what's going to be the door of the furnace, or the oven rather. And I'm going to make this out of angle iron. But I made a rookie mistake when I was cutting the pieces. A real rookie mistake. I measured the blocks and of course forgot that the measurements should be made from the inside of the bevel, not the outside. So it's all a little tight. And yet I haven't got enough iron to start all over again. But again, thank goodness, there's going to be an extra strip on the top there. These things are so easy to machine or to change that I don't care. So what I'm going to do is I'm actually going to sand off some of this here in order to make that fit. So that's the first thing I'm going to do. So one problem that I've worked out here is that if I want to close the gate like this, there's no way of me putting a hinge between that, and I'd like to avoid putting another piece of angle iron on the inside, because then it's going to be a problem getting a nice clean fit, although I could cement on another piece internally. But I'm wondering if the easiest thing to do would be to cut a piece, a flat, weld it here, along here, so that I'll be able to hinge it, and along here at the bottom to support it, so that way it'll hinge like this. So I think that's what I'm going to try and do in the first instance. I hope I'm not making a mistake. I think this one's going to be a bit of trial and error. So I wanted to maybe explain it a bit more, with a bit more sense. What I was trying to do is I've welded a piece here and a piece here, so that actually when I mount the hinges, they actually work like that. So that was the thinking. So I'm a bit nervy about the next bit, which is actually fitting the hinges correctly so that this closes flush. So that's the next job. As I may or may not have mentioned, I bought the wrong kinds of hinges for this project. As you can see, there is this part of the hinge here which will stop, which is causing all kinds of difficulties to my dimensions and everything. So what I should have ordered are butt-fitting hinges. I've ordered some. They should arrive today. Thank you very much, Amazon. But meanwhile, what I thought I would do is to carry on with the construction of the door, despite that, in terms of bricks. And I will also be coating the inside of the oven with a solution that I've stolen from another YouTuber, but I will talk about that when I'm doing it. If I haven't mentioned this before, if you're going to undertake this job, make sure, one, that you have a really good respirator, because this stuff kicks up dust like I've never seen. It's even somehow seems worse than grinding knife handles and grinding steel, although it probably isn't. And also it leaves dust everywhere, so you have to vacuum all the time. So make sure you've got a good respirator and a good workshop vacuum cleaner. I'll just interject for that. So here is one brick that I've cut the size. Number 2 brick. And now I need to fit something in there. As I mentioned before, one of the YouTube creators that I watched who made one of these ovens, a guy called Loz Harrop, and I will put a link to his video below. He had a very interesting concept which none of the others had, or at least none of the others I saw had, which was to coat the inside of the oven with something that will help preserve it, make it tougher and less brittle. Because as you've seen already, this stuff crumbles into dust really easily. And I'll tell you one thing, I'll be delighted when I'm done with this project because I'm sick of white dust everywhere. But And what he coats it with is a solution made out of liquid sodium silicate, zircon silicate, and porcelain powder. And you wipe it on the inside of the oven and it gives it quite a strong coating. And here's one that I did earlier, although you will also see this in his video. So this is the uncoated stuff, right? And this is the coated stuff. I hope you can see that it is a considerable difference. I also was doing tests to see if I could still get the staples in after I coated it, because I'm going to use staples to try and secure the coil in place. And I can. So I'm going to make this solution. Now, I tried to research where he got this from. I looked it up. I haven't found any particular resources. But basically what it is you're making a sort of a liquid coating that when the oven is on will start to set, probably a little like porcelain is my guess. So I'm purely following Loz's recipe here. And it's going to be 2/3 of the zirconium powder, there, to 1/3 of the porcelain powder. I just got these from a pottery supply company. It wasn't hard to find. There, that's 2/3 to 1/3. Now, the liquid to make the paste is going to be made up of liquid sodium silicate. This, unfortunately, I don't want to put that much in. How am I going to measure that? Well, I'll probably use the same spoon, actually. So that's 50-50 with water. So I'll probably put, this actually is an 80 ml measure. So I'll put 2 of those in. Oh, let's make it 3. I can't imagine I'll be using this stuff all that often. Again, this came from the pottery supply company. And I'll put 3 of water. There. So I'll mix that up. So now I'm going to add this liquid. I should be using gloves, actually. I think that sodium silicate is quite it's not good for you. Yeah, so sorry, I had to have a bit of a rethink. I've added more powder and decided to put some gloves on. Be a little bit more responsible and safety conscious. I'm sorry I hadn't done it before. So I'm going to just coat the inside and the base here, and then I will also coat the a portion of the lid. There, that's all I'm going to do, and then that's going to dry, but as I say, it won't really cure until it's under a lot of heat, so that the porcelain obviously glazes. Okay,